Audio Jungle.
Hi, good day. I am Irah and Federnal from BSCE-1B, and today I will going to discuss how our code works in problem 1 and also what are the flow of this problem. I will read first the problem and next I will discuss how will it flow. Problem number 1. Write a C++ program to calculate the volume and surface area of a structure. The program should take the length, width, and height of the structure as input from the user and calculated volume and surface area. In order to make solution for this program, assume that the needed structure is a perfect cuboid. The first step we did is we start our program with a rounded shape rectangular. Second, variable length, width, height, volume, and surface area are declared as double. Next, the program displays the message. This program calculates the volume and surface area of a cuboid structure, and a new line is displayed. Next is the program display the message, enter the length of the cuboid structure. And for that, the user will provide an input for length, which is read and stored in the variable length. The program displays the message, enter the width of the cuboid structure. The user provides an input value for width, which is read and stored in the variable width. And next, the user provides an input for height, which is read and stored in the variable height. The program calculates the volume of cuboid structure using the formula volume equals length times width times height and stores the result in the variable volume. Next is the program will calculates the surface area of the cuboid structure using the formula surface area equals 2 times length times width plus height times height plus width times height, and stores the result in the variable surface area. Next is the program will display the message volume of the cuboid structure and followed by the value of volume. Next is the program will display the message surface area of the cuboid structure followed by the value of the surface area, and therefore our program ends.
And now, let's go to our coding. The first 5 line in coding is automatic if we are making C++ program. So now, I will going to proceed to the next step that we do. We put length, width, and height as a process, and we see out this program calculates the volume and surface area of a cuboid structure in meters. And after that, we put a command saying ask the user to input length, width, and height of the cuboid structure. So, if we were going to see out it will look like enter the length of the cuboid structures in meters, and it will indicate the length of the cuboid. And next is we see out enter the width of the cuboid structures in meters, and therefore it will going see in the width. And for the next see out enter the height of the cuboid structure in meter and see in the height. And after that, we put a command calculate the volume of the qubit structures using the formula volume equals length times width times height. So basically, if we double it, it will become volume equals length times width times height. And the next command will be calculate the surface area of the qubit structure using the formula surface area equals 2 length times width plus 2 length times height plus 2 width times height. And next command will be display the calculated volume and surface area to the user.
And after that command, it will see out the volume of the qubit structure is a cubic meter, and other one is the surface area of the qubit structure is in square meters.
For the second problem as given, write a C++ function named calculate still quantity that takes the following parameters. Here are the lengths representing the length of a steel bar in meters, diameter representing the diameter of the steel bar in millimeters, and quantity as a reference parameter to store the calculated quantity of steel bars required. The function should calculate and store the quantity of steel bars required to cover given length considering the following condition. Each steel bar has a fixed length of 12 meters, and the steel bars are placed side by side without any gap. Shown here is our main algorithm, which will be discussed through using flowchart. So the flowchart is in the next slide. So here is the flowchart of our solution to the problem 2. Since the content of algorithm and its content are the same, I will just discuss its flow. Probably the starting of the program, then the declaration of the variables, which is the length and the diameter, displaying a message what is the content of our particular program, then message prompting users to input values such as enter length of the steel bar in meters and enter the diameter of steel bar in millimeters. After this, the program will read the input and store as variables, while the variables will undergo different formulas given, which will make end of the program. So here is the example of the flowchart to be used and implement as a program. The code about the calculate steel quantity function takes the three parameters: length, diameter, and the quantity. So length represents the length of a steel bar in meters, diameter will represent the diameter of a steel bar in millimeters, and the quantity is a reference parameter used to store the calculated quantity of steel bars required. So to calculate the quantity of steel bars required, the function first converts the diameter from millimeters to meters by dividing it by 1000. This is to ensure the consistent units throughout the calculation. So next, the function calculates the number of bars required to cover the given length by dividing length by the fixed length of each bars, which is 12 meters. To ensure the calculated value is rounded up to the nearest whole number, as steel bars cannot be divided, we use the ceil function from the CMAT library. So this is to be seen in the line 11, as you can see. After obtaining the numbers of bars required, the function calculates the quantity of steel bars needed by dividing the number of bars by the diameter meters. Since the desired quantity is an integer value, the result is to cast a static cast in integer, which is in the line 14. So there is a quantity is equals to static cast in bars required over diameter meters. In the main function, the user is prompted to input the length and diameter of the steel bar. The calculate steel quantity function is then called with the provided inputs, and the calculated quantity is stored in the quantity variable. And lastly, the calculated quantity of steel bars is displayed to the user using the cout statement. That is where the line 34 lies. So this code allows for an efficient calculation of the quantity of steel bars required, ensuring accurate result based on the given length and diameter while considering the specific conditions. This will end the discussion for the problem 2, and we will proceed to the problem 3.
And now, we are going to tackle the problem number 3, which says that write a C++ program to calculate the bending momentum of beam based on the applied load and distance from the support. And the second step is we declare load, distance, and beam length as double. The third is we print this program calculates the bending moment of beam base on the applied load and distance from the support. And the fourth step is we print a new line character for us to prompt the user to enter the applied load in kilonewtons. Therefore, it will read the input and store it in load. Next is prompt the user to enter the distance from the support to point of interest on the beam in meters. And after that, it will read the input and store it in distance. And it will prompt the user to enter the length of the beam in meters. Next is it will read the input and store it in a beam length. And for the next step, let us declare bending moment as double. If distance is less than or equal to beam length over 2, then do set bending moment equals load times distance. Else do set bending moment equals load times beam length minus distance. And next step is it will print the bending moment of the beam is followed by the bending moment and kilonewton. And for the last step, let's end the program. 3 variables are declared to store the input values load, the apply load in kilonewtons, distance from the support to the point of interest on the beam in meters, and the length of the beam in meters. Next is the program outputs a message to console explaining the purpose of a program. The program prompts the user to enter the apply load by displaying the message enter the applied load in kilonewtons. The user's input is then stored in load variable using the cin object. Similarly, the program prompts the user to enter the distance from the support to point of interest on the beam by displaying the message enter the distance from the support to the point of interest on the beam in meters. The user's input is stored in the distance variable. The program prompts the user to enter the length of the beam by displaying the message enter the length of the beam in meters. The user's input is stored in the beam length variable. Next, the program checks if the input distance is valid. If the distance is less than 0 or greater than the beam length, it displays an error message indicating that the distance is invalid. The program then exits by returning 0. If the distance is valid, the program declares a variable calculate bending moment to store the calculated bending moment. The bending moment is calculated based on the distance using an if-else statement. If the distance is less than or equal to half of the beam length, the bending moment is calculated as the product of the load and distance. Otherwise, the bending moment is calculated as the product of the load and the difference between the beam length and distance. The program will display the calculated bending moment by outputting a message to console using cout. The bending moment value is concatenated with the message. Finally, the program returns 0 to indicate successful execution of the main function, and the program terminates.
For the fourth problem, we need to provide a program to determine the type of soil based on its moisture content. So here is the provided algorithm of our program considering the flowchart next to it. In this flowchart, it will show the flow of program to be executed as a code using the C++ language. Basically, the first step in the flowchart is to start the program, followed by the declaration of the variables, then the displaying the message through the user in order to understand what the type of program will be provided. Next is the input of the moisture content of the soil through percentage, and then the reading its variable and storing it as a moisture content. Coming through the decision, what will it become the type of soil based on its percentage. So I will be discussing this thoroughly using the code provided next slide. In the main function, this program will starts by the displaying an introduction message using the cout statement in order to user to understand what type of program are we doing. The user is then prompted to enter the moisture content of the soil using percentage, and the entered moisture content of a soil will be stored as a moisture content variable. The program will determine the type of soil using a conditional statement else, if, and else statement. The first condition will check if the moisture content is less than 10%, and if yes, then print dry soil. If the first condition is false, then the program moves to the next conditional statement wherein if the moisture content is greater than or equal to 10% but less than 30%, then the program will print as it is a moist soil. Otherwise, if it falls, the program will continue another conditional statement wherein if the soil is greater than or equal to 30 and less than 60%, the soil should be considered as a wet soil. Otherwise, if it increases to 60%, then the soil considered to be saturated soil. Finally, the program will end by returning it to the 0 from the main function, indicating successful program.
Good day, programmers, engineers, students, and other audience. I am Tyron Monteclaro from BSCE-1B, and as a member of this group, I am assigned to discuss to you the last problem in this project. And in this fifth problem, we are assigned to calculate the total load on a bridge or on a certain bridge using this program. The program should take the following inputs from the user, including the number of trucks or the vehicles present in the bridge, as well as the truck weight and the number of axles on those trucks or on those vehicles. Each of these variables represents a specific concept of the program, which is very important in the overall output of the said program. As a clarification, the truck weight or the variable for truck weight represents the weight of the truck in tons or in 1,000 kilograms. On the other hand, the truck axles represents the number of axles present on that particular vehicle. It is important for us to know that axles greatly affect the weight of a particular vehicle because it greatly affects the load on a particular vehicle through suspension. Additionally, we are provided to assume that the following load distribution factors of the vehicles are based from this concept. So for trucks with 2 axles, 40% of the weight distributed into the front axle. On the other hand, the remaining 60% is distributed to the rear axle. So for trucks with more than 2 axles, 30% of the weight is distributed from the front axle, and the remaining 70% is distributed equally among the rear axles. So since vehicles usually have one axle in front and one axle in the rear, if a vehicle is having 2 or more axles, there are more axles in the rear to support the vehicle. So it is important for us to conceptualize that vehicles usually only have one axle in front, and the remaining axles are usually in the rear of that particular vehicle. So all in all, we are asked to code, to create an algorithm, and to create the flowchart of this program, which the main task is to calculate and display the total load on the bridge based on the overall number of the vehicle present on that particular road or bridge. So programmers, engineers, in order for me to effectively describe the content of this particular program, I am going to use our flowchart. Why? Because it is greatly effective for viewing, and I can effectively or efficiently describe the content of the program. So the program will start. It is followed by, we are going to declare the variables which are the number of trucks, the truck weight, and the truck axles. I have already explained why these three variables are the most crucial part for this program, because they greatly affect the total load of a particular bridge, whether that is a suspension bridge or a normal bridge. So the next part in the program, we are going to display quotation. The program calculates and displays the total load on a bridge. That is the title of this program. If a user will use this program, he or she will first see that particular sentence. So next, display, enter the number of the trucks crossing the bridge. This is a direction that the users will use in order for them to understand what is the action that they are going to do when they are engaging in this particular program. So the next part is read the number of trucks. So this part usually represents the input or the inputted data of the user. So after the user sees the enter scene, so he or she will input the particular number of trucks. So that particular input will be read by the program. So guys, the next part of the program is a process wherein we are going to declare the total load is equivalent to 0. Why? Because when the bridge has no vehicle at all, the total load in that bridge is 0. Meaning, we are going to disregard the actual weight of the bridge, disregarding the concrete, disregarding the steels, disregarding all the materials present on that particular bridge, except for the vehicles or the trucks. Another declaration that we are going to do is the value of the incremented variable. The incremental variable is equals to 1. Why? Because 1 is the smallest value that we can put in the variable, which is the number of trucks. So after that, we are going to go into a decision in this flowchart, which is stated that if the incremented value is less than or equal to the number of trucks, if the decision is yes, enter the weight of the truck. So the next is read the weight, wherein the inputted value of the weight of the truck from the user will be read by the system. We enter the number of the axles on the truck. So after that particular inputted data will be read again by the system. So after that, we are going to undergo a loop. The increment formula will be I is equals to I plus 1. So every time a loop occurred, 1 is added to the incremented variable. So if the decision I is less than or equal to the number of trucks turns out to be a false statement, it will go to the another segment of the flowchart. If the truck axles is equals to 2, if the answer is yes, then the load is equals to 0.4 times the truck weight plus 0.6 times the truck weight. So that particular formula is based from the given value of the in the direction presented to us by our instructor. So if the truck axles is equal to 2, equivalent to 2, the front axle is equivalent to 40% of the total weight, and the remaining 60% is equivalent to the rear axle of the truck. So after that, if it satisfies the condition, then it will going to display the final statement of the program, which is to display the total load on the bridge in tons. On the other hand, if that particular statement turns out to be a false statement, then it will undergo another condition, wherein the condition is if the track axles is greater than 2. So if there is two or more axles in that particular vehicle, then it will undergo this segment of the program. Load is equals to front axle plus the rear axle. So all in all, the total axles are going to be summed up in order to gain the load of that particular vehicle. So the final part of this segment will be the summation of all the loads of the vehicle. So we are going to declare a formula wherein the total load is equals to the summation of the load. On the other hand, if the given value of the axles turns out to be not a whole number and does not satisfy any of the conditions, it will fall into an output data wherein it will state invalid input and will eventually lead to an end of the program. So there are two main options regarding the track axles, wherein if there is two axles and if there is two or more axles. If there is one axle, it will be an invalid input, and if there is no axles inputted in the program, it will be also an invalid. So in terms of axles, the smallest value that we can put in this program is 2, because any vehicle contains 2 or more axles. So programmers and engineers, I am going to show you the actual process in using this particular program. So as you can see in the screen, the program calculates and displays the total load on the bridge, and it is stated for us to enter the number of trucks crossing the bridge. So after that, let's say for example we input 3. There are 3 trucks crossing the bridge. So the program will output the statement, enter the weight of the truck. We are asked to enter the weight of the truck 1 in tons. So let us say 15 tons or 15,000 kilograms. So enter the number of axles of that truck or the truck 1. Let us say 2 axles. Since there are 3 trucks, we're going to repeat this process 3 times. So enter the weight of truck 2 in tons, 10,000 kilograms. Enter the number of axles of truck 2. Let us say 3 axles. Then enter the weight of the truck 3 in tons, which is 1,700 kilograms or 1.7 tons. Then enter the number of axles of truck 3, which is let's say 2. So if all of the values of all of the variables are inputted properly, the program will automatically calculate the total load of the bridge. So the total load of the bridge when there is 3 trucks crossing the bridge is 23,200 L. Mainly, the program uses increment loop, wherein we are going to add all of the weight together in order to gain the total load of the bridge. We are going to disregard the weight of the bridge because we are only calculating the weight of the vehicles present in that particular bridge. In order for us to avoid any incident, in order for us to effectively and efficiently construct bridges, in order for us to come up with signage for how much capacity can a particular bridge hold in terms of the weight of the vehicles, because sometimes there are cases wherein bridges are damaged and causing accidents due to overweighting the particular bridge. So this program can eventually or hopefully help many construction fields. So once again, I am Tyron James R. Monteclaro from BSCE-1B, and as a conclusion, I end this particular segment of the project. Thank you and have a